Hello everyone. Today we're going to take a look at Unit 3, Lesson 7, the factoring using any method. So remembering the strategies we've learned so far for factoring, depending on what kind of algebraic expression we have, we're going to look at a couple other special cases today. So let's first look at these binomials we have here and expand and simplify them and see if we notice anything. So if we have x plus 2 squared, that really is x plus 2 times x plus 2. Right? We're multiplying by itself. So if we go ahead and FOIL this, we have our first terms, our outside terms, our inside terms, and our last terms, and we'll combine our like terms. Okay, we'll do that again with the next binomial. So we have x minus 3 times x minus 3. So same idea, we will FOIL. We'll have x squared minus 3x minus 3x plus 9, and we'll combine our like terms. Okay, so the two binomials that we've just expanded, they're very specific as well. Not to be confused with a difference of squares. Remember, a difference of squares has only two terms, and there has to be a minus between them. This is what we call perfect square, and I'm just going to put a little caret in there, trinomial factoring. Okay, so a difference of squares is only two factors. This is going to be always three factors, so it's a trinomial. Here's some things we have to know, though. In order for it to be a perfect square trinomial, meaning we can use this strategy I'm going to show you in a minute, is that it must have three terms. You must be able to square root both the first and the last term. And then the operation sign minus or positive on the middle term indicates the sign for the binomial. So we'll look at what that means in a minute. I want to add a fourth bullet, okay? So the middle term must be equal to whatever we find the square root of a to be and the square root of c to be. When we multiply those together and times that by 2, the middle term must equal whatever that number is. So let's give it a try with this first one, and we'll kind of walk through some of those bullets together. So must have three terms, so it checks that. You must be able to square root the first term and the last term. Okay, so the square root of x squared is x, so that's true. And the square root of 49 is 7. Okay, so we check that box. The operation sign, plus or minus on the middle term, indicates the sign for the binomial. So we're going to have x, we're going to have 7, and we're going to take, on that middle term I have a minus, so we're going to put that in my binomial. Okay. From there we need to do one more little check. Does that middle term equal 2 times the square roots of our a and our c? So remember, we're going to check that 2 times a times c is true. So the square root of a was x, and the square root of c was 7. So if we multiply all those together, we're going to have 14x. Okay, so you can see that checks, it equals that middle term. So we have to make sure that's always true. Now when we're factoring, we should have two binomials. Because it's a perfect square, it's going to be the same binomial, x minus 7 2 times. So it would just factor to x minus 7. Let's try that next one. Three terms. We're going to use that middle terms sign in our factors. And let's do our little check here. Does the square root of my first term times the square root of my last term times 2 equal my middle term? So we would do 2 times m times 8 that equals 16m. So we can check that as well. So that's also true. Okay, so the square root of m squared is m. Square root of 64 is 8. We'll have m, we'll have 8. We take whatever sign is on our middle term, and then we square it. So we could use SPF on any of these, and if you don't like this new strategy, that's okay, you can use SPF, but this is a little bit of a shortcut. All right, next example. We'll do our check again. So if we did the square root of our first term and the square root of our last term, those both look like square roots. So they also hold true when we do that little middle term check. So 2 times the square root of 9x squared is 3x, and the square root of 36 is 6. So 2 times 3 is 6. 6 times 6 is 36x. So does that line up with my middle term? It does. Okay, so again, we're going to put the square roots in our bracket. So 9x squared square root is 3x, and 36 is 6. We bring down that sign from the middle, and we square it. The next one we're going to need to look at are these perfect squares? 2b squared is not a perfect square, neither is 128, but we should always first, before we try any other special case, we should always try to common factor first. So if I look at my terms in this, hopefully we can see that we can factor out a 2. So let's do that. If we factor out a 2, we're left with b squared plus 16b plus 64. Okay. Now if we take the square root of those, okay, we still have our 2 out front. The square root of b squared is b, and the square root of 64 is 8. We bring down that sign, and we raise it to a power of 2. If we want to do our little middle term check, we can do 2 times b times 8, and that equals 16b. I just don't want this b looking like a 6. There we go. Okay, so that checks. My middle term is 16b. Okay, the last one we'll take a look at. This one is bigger numbers, but don't let that throw you off. And also pay attention to they've thrown in some extra variables. So if we square root our first term, okay, the square root of 121 is 11. The square root of x to the power of 4 is just x squared. And then can we square root our last term? It'll be 12y. So that's what goes in our brackets. We'll have 11x. We'll have 11x squared. We'll have 12y. And then we'll just bring down that minus sign. And you can go ahead and do that little middle term check if you'd like, but it should work out to a minus 264. Okay, so that's perfect square factoring. We're going to look at one other factoring that we've kind of been using throughout, but we just are going to focus in on it. And that's going to be a factor by grouping. So we essentially common factor out of some group within an algebraic expression and not out of the whole thing. So this first one, if we look at, we're going to look at just common factoring, remembering what exactly that looks like, and then how that can be represented in different forms. So if we have 3x minus 6y, our common factor is a 3y. So we're going to divide both terms by 3y. 3xy divided by 3y, those cancel. We're left with x. 6y squared divided by 3y, well, those go to 2. And we're left with just 2y. Okay, b, we've seen something similar to this before where we have a common bracket. So I'm going to pull out or divide everything by my common bracket. So if I pull that common bracket out front, you write the result of that division inside the next set of brackets. So you can see m minus 3's cancel out there, you're left with 2m, and then m minus 3's cancel out here, you're left with plus 5. Okay, so those grouping or common factoring, we've seen those before. We're just going to look at those in different ways. It's generally always going to be 4 terms, and we're going to want to group together terms where we can common factor something out. So if I look at this next one, I have am plus an times 5m plus 5n. Okay, so if I group my first 2 terms together, I should be able to common factor out an a from here. If I group these 2 together, I can common factor out a 5. So if I pull an a out, okay, my first group I'll be left with m plus n. If I pull a 5 out from my second group, I'm again left with m plus n. Now I'm going to pull out that common bracket. So I can pull out my m plus n, and then the result of dividing that is what we're going to put in that second bracket. So if I pull out an m from n, or m plus n from here, I'm left with just a. And when I pull out an m plus n from here, I'm left with just plus 5. Okay, let's look at one more together, and then I'll get you to try that last one on your own. So, if I wanted to common factor something out of this group, and then I'll common factor something out of this group. Keep in mind that we're always going to pull out a factor with the same sign as the first term. So in our first group there, we have a positive 3x. So we're going to pull out a positive whatever common term. So in this first group, the only thing that's common there is x. So we'll pull out a positive x. In my second term, we have a negative 6 and we have a negative 4y. Well, my greatest common factor there is going to be 2. And because my first term has a negative on it, we're going to pull out a negative 2. Okay, so in my first term, I'll pull out an x, and I'm left with 3 plus 2y. In my second, I'm going to pull out a minus 2. So when I pull out a negative 2 from a negative 6, I'm left with a positive 3. When I pull a negative 2 out of negative 4y, I'm left with a positive 2y. Then I'm going to again pull out that common bracket, and you're left with x minus 2. Go ahead and see if you can factor the next one using grouping, and then come back and check your answer. So you should have gotten, just by group factoring, factor by grouping, you should have gotten something that looks like this. 2a minus b times 4 minus b squared. Now we have a b squared term in one of our brackets still, so we should always look at, can we factor either of these any further? This bracket here is a difference of squares, which we learned about on yesterday, or in the previous note. So we're going to factor that further. So we're going to leave our first factor alone. We can't factor that any further. But 4 minus b squared, okay, we can factor that using our difference of squares. So we take the square root of 4 is 2, and the square root of b squared is b. We put both of those in a set of brackets. One is going to be plus, and one is going to be minus. Okay, that's all for your notes for today.